few days ago I posted a video on spindle runout on the Mini Lathe, and I got to thinking about some of the issues there and decided I'd like to do a follow-up, which is this video, having to do with runout associated with the three-jaw chuck. The concepts I'm going to be talking about here are really directed towards new lathe workers, new metal lathe workers. So if you've been using a metal lathe for a year or more, there's a good chance you're pretty familiar with the topics I'm going to cover here. So you may not want to spend your time on this one. But I hope there's some good material, and if you're real new to working with metal lathes, you might find a few tips here that explain some mysteries that you've either encountered or probably will encounter if you haven't already. So hope you can find some good material here. Thanks. For our first runout test with the chuck, I'm going to just take this shank from a broken end mill and chuck it in here. It's a little less than 5/1000ths of runout, and that's what we call total indicated runout, or TIR. You may have seen that term, but it's just the full swing of the indicator. So let's check the concentricity of this over on the measuring bench, and just to make sure that piece really is round. I have the end mill shank set up here in a V-block. There's a precision V-block, and I've got two heavy 1-2-3 blocks holding it in place just so I don't inadvertently move it while I'm trying to rotate it. And I have the indicator set up. Let me see if I can move in a little closer here so you can see what's happening with the indicator. Now what I'm going to try to do is rotate this carefully. Let's first put some preload on the indicator so you can see that we are indeed touching. Now I'm going to use my finger. If you look carefully, you may be able to see there's some writing on the shank there, and you'll see that rotate around, or maybe you will. Let's see if I can zoom out just a bit there. Okay, and I'm now rotating it around. If you look at the indicator needle, you can see there's virtually no movement, or maybe if there is, it's probably well under 1/10 of 1/1000th. So we know this piece is very round, and that's what you'd expect since it's a end mill shank, and it has to fit tightly into a collet or an end mill adapter. Just for comparison, I've taken a piece of 6061 aluminum stock here, and I'm going to rotate it. You can see the needle's jumping all over the place, and that's mainly because the surface isn't really that rough, but as I try to rotate it, let's use two hands here and it'll be less bumpy. There you go. So mostly what we're seeing here is some surface roughness, but there's probably well over 1/1000th of runout as we go all the way around the diameter. So that's pretty typical for, rough stock. If you're using something like drill rod, it would be a lot less runout and a lot smoother. Another factor to be aware of is that with a three-jaw chuck, the jaws are numbered, and they should be installed in a specific sequence of 1, 2, 3 as you go clockwise around, as you turn the chuck clockwise around. And I've marked on my chucks, I typically put little punch marks here. So I have one punch mark for jaw 1, 2 punch marks for jaw 2, and 3 punch marks for jaw 3. But if you remove the jaws and you look carefully inside, on most chucks, even low-cost ones, the the hole for the number 1 jaw will have the serial number stamped down on the face of the chuck. So if you start from there and you put your number 1 jaw in that location, then you rotate it around and put your number 2 jaw in, and then your number 3 jaw in. Now if you had 2 jaws out of sequence, for example, if you had 1, 3, 2, they wouldn't meet in the middle at all. But it is possible, for example, to put them in sequence, but not in the original starting hole. So you might, for example, put jaw 1 into slot 2, and then jaw 2 into slot 3, and then jaw 3 goes where the number 1 jaw would normally go. And there's a lot more information about this on my website on the chucks page if you're interested. Now we saw in the video from yesterday that the important surface, when it comes to using the chuck at least, is this raised boss here on the front of the spindle, because that's the surface against which the recess in the chuck aligns. And on this particular lathe, you can see that there's maybe 3 to 4/10,000ths of run out there. But anything under 1,000th is pretty good. Under a 0.5 is what I'd like to see on a mini lathe. But let's put the chuck in place and see what we get. When we mount the chuck on the spindle, this recess on the back of the chuck is going to line up with that raised area on the front of the spindle, and that helps to ensure that the chuck is very closely aligned with the center line of the spindle. So let me get the screws in place, then we'll do a measurement out here beyond the chuck jaws. I'm getting ready to put a shank from a broken end mill in here, but first I want to make sure that there are no chips or other residue in here that might throw off the alignment. So if you're trying to do precision work, that's always a good idea, is clean off your chuck jaws before you insert your work. But as most of you are well aware, you can't really get precision concentricity using a 3-jaw chuck in general. And that's what I'm about to explain, is the in general part. I didn't do anything special when I clamped down on this. I just put the chuck key in the first hole that was accessible, and I didn't even notice whether I used more than one hole. But often I'll tighten it down on all 3 holes, because that, I like to think that helps to provide more even clamping force on the workpiece. But as you can see, just as I turn the chuck by hand here, there's quite a lot of movement. In fact, I don't even have enough, don't have the indicator down all the way there. But easily 6/10, I guess, or not 6/10, but 6/1000ths. But there's a lot of slop typically in the jaws themselves and the scroll behind the jaws, the tightening mechanism. And I have to be careful here with this flat, so I'll try to place that between 2 of the jaws so it doesn't introduce any further variations there. But let's try that again now, having adjusted it. And what you see is it didn't really help much. So the bottom line here is that a chuck of this quality, and it's not a bad quality chuck, this is just typical for inexpensive 3-jaw chucks. That's typically what you'll get, is something like that. Now you may luck out and get a particularly good one that is better than that, or you might get one that's a little worse than that. But that's just sort of the way it is with a 3-jaw chuck. And that's why when people want to do work that has to be precisely aligned, they use a collet or a 4-jaw chuck rather than a 3-jaw chuck. So I'll try one more attempt here. I'll loosen this up one more time and twist it around a little bit. Let me put it a little bit farther back in the jaws there, see if that makes a difference. And this time I'm going to tighten all 3 of the key positions there. Get our indicator back in place. And it's still pretty bad. So just to be sure it's not the workpiece itself, let me take this one out and try something else. Try another workpiece. This piece of material is a part of a shaft that I removed from a laser printer some years ago, and it looks like it's precision finished, but let's test it with the dial test indicator and see how it checks out. Well, as we did before, I'll just rotate this slowly in the V block, and as you can see, there's really no discernible movement. If I lift up on it, you can see it really is making contact, but as I rotate it, there's almost no visible movement on the dial indicator. So that tells us that this is a very accurately round piece of stock, or at least it has very few surface imperfections. Okay, I've got it in there and chucked in place. And what you can see is that there's still, about 5 thousandths or so, maybe 6 thousandths of runout. Let's try it over on my other lathe and see what we get. We'll take that same piece and put it on the bigger lathe. Okay, this time we're looking at the Precision Matthews PM1228 lathe. This lathe has a D4 camlock spindle, and on that type of a spindle, the registration of the chuck is on the outer surface of this boss here. And let's go ahead and turn the lathe on and see what type of runout we see there. You can see, let's zoom in on the dial indicator there, and you can see it's pretty low. It's well under a tenth. Well, I won't say it's under a tenth, but it's not much more than a tenth. You can see there's a little bump there, and those divisions again are half a thousandths or 5/10 thousandths apart. So it's pretty good, and we'll check the taper surface as well. And this lathe has a Morse taper number 5, or maybe it's a number 6. Let's see, it's a number 5 Morse taper on the bore. And you can see, let's shade that a little bit, you can see it better, I think. But it's pretty low runout, you know, not more than a tenth, I would say. And that's not surprising, since this lathe costs, you know, more than 4 times as much as the Mini Lathe. And of course, if you had a $10,000 or $20,000 lathe, you might see even better results. But this is pretty good, and certainly for home shop work, it makes me happy. So there we go. Alright, well, I went ahead and mounted the stock 6-inch diameter Anomaly 3-jaw chuck. This is the standard chuck that comes with this lathe. And I've put our same test piece in here. Looks like it's got some sort of bump on there. But let's go ahead and turn it on. And zoom in on that a little bit. And we're getting, looks like about 3 thousandths maybe of total indicated runout, maybe 2.5. Let me see if I can line that up with a 0 mark there. Not that it really matters. It's actually around 2 thousandths, looks like. So, what's the difference? The difference is that this particular chuck is inherently a little better than the one that's on the Mini Lathe. But it's a 3-jaw chuck, and as I said, because of the scroll mechanism, you know, that's about as good as you can expect. If you find a 3-jaw chuck that tightens consistently to under 1/1000th of runout, you've got yourself a good chuck. And there are chucks, by the way, and you've probably heard about them or have one maybe, that have adjustments that you can, once you've clamped your workpiece in here, you can make an adjustment after that and align the chuck or zero in the chuck using a dial indicator. We're back over at the Mini Lathe now, and I've chucked that same workpiece here in the 3-jaw chuck, and let's take a readout on that. And as before, we're seeing, you know, 6 or 7 thousandths of runout. And if we go down here to this surface where it's been turned down previously, maybe a year ago, who knows, it's just a piece I grabbed out of the scrap drawer. See, there's a lot of runout there, but it's probably concentric. Now there's enough runout, and you can probably see it yourself. If I zoom in on this workpiece, it's there's enough runout that you can actually see it going up and down without even looking at the indicator. So that's a fair amount of runout when you can see it by eyeball. The next thing I want to do is take a cut, and so I'm going to advance the tool there a little bit, and then I'll just take a light turning cut here. You can hear it sort of pulsing, and that's due to the off-center nature of that workpiece. But if I make a second pass, it should be a little better. Let me turn up the RPM some. Alright, so we made a third pass and got that surface pretty clean there. Then let's put the indicator on it. Put the indicator down onto the workpiece, and lo and behold, our runout now is way lower. It's just maybe a tenth or two, and it's probably very close to or the same as the runout that we measured on the spindle itself. So that's the interesting thing that you have to keep in mind. You can see, if you look out here at this tip that I didn't turn, it's still wobbling up and down, but in the back part here is wobbling up and down, but the surface that I turned is now concentric with the spindle itself. So that's the magic of turning work in a three-jaw chuck. A lot of people don't realize this, or a lot of newbies don't realize it, is that once you take your first cut, that surface will now be as concentric as the spindle itself, or close to that. And if you now make additional cuts, I'll go ahead and turn this surface out here and turn another surface, all of those surfaces also will be concentric. So, and if we then cut that piece off and we're done with it, then we have a piece that's very concentric, regardless of the fact that it was off-center when we started. But there's a caveat, and I'll get to that, and you probably know what it is. Off camera, I turned down another section of this workpiece right here, and right now I have the dial test indicator indicating against the surface that was not yet turned, and we'll take a look at that. We've seen that before, and there's our runout that we had before. But if we now move the indicator over here to the part that I just turned and touch the indicator up against there, you can see this very little runout, you know, maybe just a few tenths. And so the lesson there is that once you take a turning cut on your workpiece, regardless of how off-center it is in the chuck, the part that you turn will be concentric with the spindle, and usually to within the accuracy of the spindle bearings. So, good thing to keep in mind. Now, here's the caveat. That's great as long as you're machining a series of surfaces that you can, if you can cut all the surfaces in one pass or multiple passes, one chucking I should say, of the workpiece, and then you're done, then everything will be great. The problem comes about is if you need to turn the workpiece around to do work on another end, when you re-chuck it to do the second end, then that end will not be concentric with the first end. So in that case, you can't use a three-jaw chuck to get concentricity. You have to go to a collet or a fourjaw. So let's look at that. I've chucked up a piece of 3/4 inch diameter 6061 aluminum bar, and it's had some previous work done on it. It has a very rough cut on here from some previous life. But I've chucked it up, and let's check the runout on the piece as it's in there right now. And again, it's around 4 to 5 thousandths, maybe a little better than we were getting before, but that's probably just the luck of the draw. So let's make a turning cut on that. I've engaged the power feed, which should give us a little bit smoother and more even cut than turning by hand. We'll make one more pass here. Well, that's good enough for what we're doing here. Let's get the dial indicator on it. Just a note on terminology. I called this a dial indicator. Technically it's a dial test indicator, but it is a form of dial indicator, and it's just a different configuration that is the advantage of a dial test indicator. It has this fine tip that lets you reach down inside of a bore or other difficult to access surface. Alright, so let's bring the indicator probe down onto the surface there. And as you can see, there's a little bit of jitter there, but it's, you know, looks like it's jittering about a half thousandth, maybe a little more, maybe a little less, but less than a thousandth in any case. That's not too bad. But let's suppose now that for whatever workpiece, whatever thing it is we're making, we need to machine another feature on the other end. So we're going to take this workpiece out, and I'll cut it off a little bit shorter, and then we're going to flip it over and rechuck it on this end, and then turn a feature on what will be this end down here. Okay, I took the workpiece over here to the 4x6 bandsaw. There we go. You may wonder why I didn't cut that off in the lathe using a cutoff tool, and the answer is it's difficult to cut things off on the mini lathe, as most of you probably know if you have one. This is an ancient 1999 model Harbor Freight 4x6 bandsaw, which has been modified quite a lot. You may have seen it in some of my other videos, but I've gotten it fine-tuned. I'm pretty happy with it. I made this nice bench for it with a big chip tray underneath. But let's get the work back over to the lathe. Okay, now I'm going to take our finished end, and before I do that, I want to clean off any chips on the chuck jaws, just because they could affect the registration or the accuracy with which the workpiece seats in the jaws. If you have chips in there or other residue, it's going to affect the alignment. And we'll tighten up on all three holes, and then just to see where we are, we'll do a test on this surface here. Okay, I've got the dial test indicator set up on there, and let's turn it on and see what we got. Wow, so we've got like what is it, maybe 9 thousandths or something like that. Quite a lot of run out there. Yeah, it looks like 10 thousandths. So what does that tell us? Well, when you take a workpiece out of the 3-jaw chuck and flip it over, when you clamp it back down, all bets are off as far as concentricity with the machine side. But let's now take a cut on this side and see what happens. Alright, I made a couple of passes over it and faced the end, put a little chamfer on it here to get the sharp corners off. Let's put the indicator on and see what it looks like. Okay, we'll turn the lathe on and bring the indicator down. And as we saw when we machined the other side, now that we've taken a couple of cleanup passes, runout's pretty good. You know, it's only like a thousandth or less, half a thousandth maybe. Pretty darn good. So it's all perfect, right? Well, maybe, maybe not. The real issue is when we flip this over, is the new surface now concentric with the old surface? Alright, so now I'm clamped on the surface that was out, and this was our original surface, and you probably already know what's going to happen, but let's turn it on and see. Whoa, back to our old runout again, and therein lies the tragedy of the 3-jaw chuck. Alright then, so that sums up our work on the 3-jaw, and I hope to do another episode soon where we'll compare that with a 4-jaw chuck and some of the reasons why you'd use a 4-jaw rather than a 3-jaw. But if you're new to all of this, I hope you learned a few things, and if you're not new, I hope I didn't bore you to death. But in any case, thanks for watching. See you next time.